Hello.
Hi.
Hi. Welcome
Hi.
to episode 2. Code School.
Code School.
Code School. How's it going?
We're still not cancelled.
Still not canceled. They picked us up for episode 2. We don't
Um,
know about season 2 yet, but at least we got episode 2 done.
Exactly.
How's life? You good?
Life's good.
You good?
Life's very
Nice. How's everybody in chat? For those of you watching in chat. All good?
They seem to be good.
So
Seem to
last
be
week,
happy. Yeah.
last week we went through some basic stuff. Nailed some functions. We made a logo move around. It was pretty intense. This week, what are we doing this week?
We are going to get more stuff moving around,
Nice.
but through the keyboard. And we're going to do a lot more conditions. We're going to write more functions.
Oh,
and maybe a little art from the community.
Oh snap!
Mm-hmm.
Oh snap! This is a surprise to me.
I asked the people on Discord to make a little spaceship. So that'll be fun.
Sweet. Did you do you wanna get going?
Let's
Good?
get going.
Good.
Mm-hmm.
I'm gonna swap over to your view.
Mm-hmm.
Bam.
There we go. And I've fixed the case where our cameras are gonna hide everything. That's good.
So class starts now.
Class starts now.
Everybody be quiet.
Hi, Gabe.
Hello.
How are you?
I'm doing good.
People called this cringy last time, but hey, it's fun.
This is I don't know what you're talking about. Cringe is the best anyway.
We're back.
Oh yeah,
Episode 2.
we are.
We had a lot of fun last
It
time.
was pretty good.
Pretty good. Logo moving around, having
Yeah.
fun. So let us refresh our memory a little bit from last time. It's good to refresh. So if you didn't follow up or if you didn't practice after between the 2 episodes, that's fine. It's still important. It's very important to practice regularly. But let's refresh our memory. So last time we talked about 3 concepts. Well, actually, we talked about 4 concepts.
We got lied to. We got debated.
Baited, like those kids say. Concept number 1 was variables. Do you remember what variables were, Gabe?
Yeah, it's something that holds a value.
Holds a value.
Holds a value.
A variable is a way to store numbers in memory.
It's close enough to what I said.
It's correct as well.
Yes.
I'm not unhappy with that one. Here's an example. We have a number, which is an integer. We name it something, current year, and we put a value in it equals 2018. And we put a semicolon, and semicolons are to end one-line statements. All right? Another way, same thing, int current year is equal to 2018. After we have declared it, we can change it afterwards. So we don't have to put the int, because the computer already knows, since you gave it the name current year, and it is an integer, it can't change the type. So it is a type, a name, a value. And after you've declared it for the first time, you cannot change the type. And you can also use a variable to set a value for another variable or its own variable. Okay. Concept number 2, conditions are used to ask variable questions.
Hello, variable. How are you doing today?
How are you doing today?
How's that for cringe?
And the answers can only be true or false. You can't ask, like, what are you? You have to say, are you this?
If it answers what it is, I think we have bigger problems.
Then we have the singularity on our hands. Great. So, for example, we say if. So there are many conditions. We will go into more of them later, but one of them is called an if statement. We say if current year is bigger than 2000, then we add to the millennium. And if the condition is true, current year is bigger than 2000, then the code within the curly braces will execute. Otherwise, we'll jump over it. We'll go past it. Sounds good?
Sounds good.
Concept number 3, functions. So a function is a way to take code you have written and isolate it so it can be reused again and again. It's just regular old code. There's nothing different about that.
Regular old code.
Regular old code. Good old code. And concept number 4 is a thing I call abstraction, which is a common term within programming. And there are many ways to describe abstractions. I'm going to use this one for now. but if you Google it, you'll find many ways to think about it. But for now, I would like to think about it this way. An abstraction is an idea. It's not syntax. It's not any kind of feature within the language. It's just an idea of hiding complexity by creating a layer above it. An example I like to use is if you think of a car. Do you know what happens when you press the gas pedal in a car, Gabe?
Yes, you go forward.
Go forward.
Unless you're not in gear.
Not in gear. So let's say you are in gear and you press the gas pedal, and if the car is running.
Yes. Oh shit.
So we have two conditions here. If car is running and if in gear, right? Those both have to be true. Then when you press the gas pedal, the car goes forward. So do you know how it goes forward? Do you know all the technical details of what happens when you press the gas pedal?
No, I don't.
Do you care?
Something spins and it goes forward.
Do you care?
No.
No.
If it functions, it's good.
If it functions. What a lovely word. What a lovely word.
I didn't even do that on purpose.
No, it's good. I caught it. And if you switch cars, generally, I would say, if you press the gas pedal in that car, it also goes forward. But it might be different in how it does it, right?
Might go forward faster.
Or also like the mechanisms in the engine are most likely not the same or not exactly the same. And that is an abstraction. You press the gas pedal, that is the interface, and then the car goes forward. So in our last episode, we called a function that creates a spaceship. Did we care how? Well, not when we were calling it, but when we were creating it, we cared. Okay? Sounds good. Sweet. But so let's do another review that I found from the last episode. I saw you had some trouble with the function syntax, how you write functions, how you define functions. And I want to go through a little exercise that I go through with people that I teach. It seems to help. It doesn't mean it does help. So this is
we just dropped a lot of frames again.
It seems to be stable again? Okay.
I went down. Just for everybody, so it won't be relevant for people watching on YouTube. For some reason, we are dropping a lot of frames. Hey, Mitch, what should we do? Oh, there it goes again.
So, I was reviewing last episode, and I saw that you had a little trouble with the function syntax. And the idea is, this is a way or a method I use to teach people about functions and function syntax and how they are called and used. This might not help everybody, but if it helps somebody, that is great. So, yeah, this is one way of thinking about how to use and call functions. So, let us think about this. 2 plus 3. Okay.
Quick maths.
You might not know or think about it that plus, not 2, is a function. It is a function that adds 2 numbers together and then returns the value. But it's in the middle, right? So it's 2, and then the function we want to call, and then 3. What happens when we want to add more than 2 numbers together?
You add another.
Add another plus. Yes. So there's always plus always takes 2 numbers, never more. But can you read from this view which one you should do first? And if you ignore what you learned at school about like which one is done first, it is obvious from there which one should be done first.
I just assume the leftmost one.
Leftmost one, sure.
First one.
Yeah. In when you're adding numbers, it doesn't matter. In other cases, it does matter, but it's not obvious from this syntax. So let's go back to 2 plus 3. It's gone. Let's go back to 2 plus 3. Let me do one thing. And for some people, it will mess with their heads a little bit.
Oh.
But that's good.
I'm probably one of those people.
Yeah. So can I do this?
No.
I just moved the plus.
Now it doesn't work. Now you're positive 23.
Positive 23. Yeah, exactly. But if we think about it the same way, what is the thing I want to do? I want to do a plus. What is the thing I want to do it on? 2 and 3. Okay?
Yeah.
Seems good. So if I then want to add 3 numbers together,
okay,
I'm I want to add 2, and I also want to add the result of 3 and 4. So in that case, it is more obvious which one should be done first.
You start with 3 and 4.
Yeah, which will resolve into 7, and then you can add the 2 and 7. Yeah. Okay, but this syntax is a little confusing, right? Okay, so let me clear it up a little bit, because you said like it's 23. Yeah. So let me add a comma to separate them from each other. Okay, it's the same idea, plus 2 and then 3. A comma is just separating the list of numbers we want to add together. So if we then also go here, okay, it's a bit better. We want to add together 2, and then there's a comma. And the comma was a case of here's another number. But this is still kind of segmented out, right? Where does 1 comma, or the idea of 1 comma and an idea of another comma begin? So let me do one thing. So that will result in a 7. So let me do another thing to help with this syntax. Let me add a parenthesis around it. So we want to do the action plus. What do we want to do it on? Okay, that is the list. And the list of the things we want to do it on is the 2, 3. So if we go here, it's a bit more obvious what's going on. We want to do the action plus, and then we open the parentheses. What do we want to do the action plus on? It's a 2. Okay, that's easy enough. We don't have to do anything.
I'm not lost. Okay, I got this. I understand it so far.
It's good. We do a comma. And then what is the other one we want to do? What's the other number? Well, that's another plus. So we have to resolve that one first. That is resolved, and then we have a 2 and a 7. We can keep stacking these infinitely. You can have pluses all around. But plus, in my head, works for that case. I mean, plus, we know what plus does. But let's do one more.
Uh-oh.
Add instead of plus. And then if you go back to this one, we have add of 2 and
7.
An add of 3 and 4. The add of 3 and 4 is 7. And then the add of 2 and 7 is 9. And this is the function syntax, if you remember that from last time. So it sorry, let's go.
Let's go.
It goes from the idea that when you do plus, you have to have them in between the actions. But what if you want to have more than one? That doesn't work. So we separate the action outside. We add a comma to the list of the values that the action is going to use. And we separate each action by parentheses.
Bam.
And that is the function syntax.
That's 9.
That is 9. That's one way of doing 9.
Yeah. It's like a very complicated way of getting to 9, but you got there eventually.
You got there.
But you could replace 3 and 4 with like X and Y.
Yes.
So you wanted to add other numbers there.
Correct.
Nice.
Correct.
Sweet.
It works because add will return you a number, and add also wants a number.
And 3 and 4 are variables, and you can give...
If the variables are numbers, you're good.
But if they're X and Y...
Yep. And if the X and Y variables are defined as numbers, again, you're fine.
Nice.
Yeah.
So I can't add, like, fish and horse?
Correct.
Damn it.
Unless you define what happens when you add together fish and horse. You get a fish horse, right? Good.
Or human and horse, you get a centaur.
There we go.
There we go.
At least you have defined it. So, let's go.
Let's go.
Let's switch over to our dual view.
Dual view. Which one is this one? Bam.
There we go. Maybe we should set it up so...
I gotta do my void setup stuff.
Mm-hmm. For people watching, you would go to openprocessing.org, and there on the website, maybe I can show it while... can you show it?
I swapped to your screen.
Okay. Go to Open Processing. If you have a user account, that will be here. And on the front page,
I think you might be able to. Did I make one for that? Oh yeah, I made an exclamation mark tool,
Okay,
which
good.
explains a little bit of how to get to the website and what we're doing.
Yeah, it's kind of annoying if you are actually logged in. Anyway, on the front page, if you're not logged in, on the middle of the page, a little bit down, there's a thing called Create a Sketch, or you can go to openprocessing.org/sketch/create. That should be the thing. And what you have to do is, since we are not using p5.js, we're using processing.js. We have to switch to that one. That's the only thing you have to do. So let's set up. Let's leave this. And let's go back to our dual view.
Oops, not code review.
Not code review. Let's maybe increase the size a little bit. So the goal for today is to get a box on the screen and move it around with WASD. That is the main idea for today. What we're going to do is we're going to go through these steps in a way that they make sense in the beginning, and then it's nonsense. No, they make sense in the beginning, but it doesn't work necessarily. There's going to be bugs.
Oh yeah.
And we're going to fix them, because the end result that actually feels good, moving the box around with WASD, if you would look at that code just by itself, it doesn't make sense why we're doing these things. So instead of just saying, oh, you have to do it like this, let's go through why we have to do a thing. So we're going to implement it in a naive way in the first iteration, find the issues, solve them, find more issues, solve them, etc., until we have an actual solution where we have a box and we can move it around. Sounds good?
Sounds good.
And we can also play with it a little bit.
Yeah.
Yes. So, as before, we would like to set up our screen. So if you don't know how that is done, we can also refer to the first episode where we talked about this. So the size of the screen, which is a function that we call, is going to be 800 by 600. The background, which is going to set the color of the background of everything, is going to be 0. We're going to have a black background. You see my shirt? Yeah, it's a good shirt.
Praise the sun.
Frame rate is going to be 60. We like those 60 FPS.
That's acceptable.
Acceptable.
It's acceptable.
And we're also going to call a function called no stroke, and it doesn't take any arguments. So here we are calling 4 functions. These functions are defined by the processing language. There's no difference from these functions and any other functions that we write ourselves. It's just they have been defined already, and they're just hidden from us. But somewhere in the code, in the library, there is a function called size. Simple as that. And it takes in 2 numbers like our function add would. Background takes in 3 numbers. Frame rate only takes in 1 number.
We are dropping again.
We're dropping frames again.
Disconnected. All right. So where were we? Maybe we just go back to the setup.
Yes.
Finish off the setup part. Point.
So the idea with the setup, so we have, we create 2 functions within processing. So we are creating a function called setup. It is void because it does not return anything. And here we have the parentheses from before because we don't take in anything. And these functions are required by processing. And processing will call these functions by themselves. So setup will be called once, and draw will be called this many times a second. That is the idea.
Glorious 60.
Glorious 60. So we have a function called size, takes in pixels, height and width. We have a background, which is the color, RGB, frame rate, frames per second, and then no stroke doesn't even need to take in anything because we will modify how these, when we draw a box, we don't want an outline on the box. Sounds good? Sounds good. And now I want Gabe to write some code, and we're going to review it.
Oh, snap.
The idea is to create a box that is has some x and y coordinates and is 32 by 32 pixels in size. And I would like you to create a new function. Like these two here are functions.
Yeah.
I would like you to create a new one. We will call it spaceship. And within the function, we would like to draw a box. Sounds good?
So I should start with the spaceship.
Create the function first, yes. Let's look at that.
Do void. We
Mhm.
call it spaceship.
Mhm.
Oh. If I start off with size,
So we would like to draw a box.
Yes,
Let me open up the reference page.
oh, it's gone.
We're just going to continue.
Yeah.
So we open up the reference page, and we are going to draw a rectangle. It's called a rect, and I will show you. So I could do this, and here, so you can see. So a rectangle takes in 4 numbers. We're not going to do these ones right here. So it draws a rectangle on the screen. Here's an example of how we can do that. And the coordinates are the x and y coordinate of a rectangle and the width and the height. We're not going to use these ones here.
So I need to start off with a rectangle because that's what we want to draw.
We
so
want to draw a
it's
rectangle.
rect.
Mm-hmm.
And the first coordinate is the x coordinate, which I will leave to. Should I just leave it as x now?
So what would be a value we could put as the x coordinate?
Okay, I could just put it as 0 if I wanted to.
Correct.
Just 0. And if we put it y as 0 as well.
Yeah.
And the width 32 and 32.
Correct. Okay. Is there more stuff you need to do?
For the rectangle, I don't think so.
Okay. But we'd like to draw this spaceship, right? So what do we have to do then?
I have to put it into the void draw.
Mm-hmm.
Which would it just be?
Okay. Run the code.
There
we go.
We have a box.
That is a pass. So let's code review that. If you switch over.
Code review.
Mm-hmm.
Bam. Just gonna full screen mine.
Let's look at the code.
F11 doesn't want to work.
It's okay.
Why? Oh. Okay. Anyway, can't F11.
So switch over to the code screen. Let's look at the spaceship. So we have a void spaceship, correct?
Yes.
It has no parameters, all right?
Yes.
Within the function, you say rectangle, yeah?
Yep.
You take in the first 2 x and y coordinates, and then 32 and 32, and you remember the semicolon. And then within the draw function, you call the spaceship function. So when you call the spaceship function, the code will actually go into the spaceship function, and then they will call the rectangle. So it is basically like calling rectangle in draw, but we are abstracting it away, if you think of it that way. Great.
Yeah.
So that is a pass.
Woohoo! Did it. Nice. Go back to the double coding screen.
Double coding. All right. We
have a spaceship. We have a rectangle.
Gonna shrink this a little bit. Be like this. Okay. So I'm gonna write up the same thing. We have a spaceship, and then we have rectangle, 32 and 32. Then I call spaceship. And you can see here mine. Yep. And I have the same setup. And
Bam.
I have a square. Great. So now we would like to move around the spaceship. And to move around the spaceship, we want to press the keyboard. Buttons on the keyboard. And like last time, to update these values, rectangles, we would like to put variables in here, where the x and y is, because that would cause the spaceship to move around. And we can do a thing right now. We can create variables inside the rectangle, inside the spaceship function. So let's create an int variable called x and an int variable called y. And let's just give it the value 0 to begin with. Okay. And let us put them in here.
Oh,
So when we hit play on that, it's still up there in the corner, but we would like to update these values.
yep.
So let's
Wait, mine's different.
There's a little bit to the side. Oh yeah, I have my screen a little.
Okay.
Yeah, it's. It didn't want to minimize the window, but it doesn't matter much. But here's the problem. What we want to do is we would like to update the X and Y values. But if we go through the code, the function draw will be called.
I'm just calling spaceship.
It calls spaceship, all right?
Which just has X and Y values of 0.
As 0. It will create a variable called X. It will create a variable called Y. It will put them here as the X and Y, which will be 0 and 0. It will draw the box on the screen, and then we will go back up. Go to draw. It will call spaceship. We will go in here. We will create the variable X again, and create the variable Y again. Put them here.
But they're still just 0.
Yeah. And the thing is, because we created the variable X here, and use it here, when this curly brace ends, these two variables are destroyed. They are taken away. We're not going to go into how they are, but we're going to go into how to use them. So, the problem is we would like X and Y to survive for every draw call. So what we want to do, and we will do this for now, and those who know a little bit about programming know that this is bad form. You usually don't do this. But we will learn how to do this now. We will learn why this isn't the greatest of ideas. And then we will learn how to solve this problem, right?
I don't know any of the ideas, so I'm just going with the flow.
Going with the flow, great. So it is simple as taking the X and Y variables, and we can cut, and let's move them above the setup window here.
Ooh.
You can take away the white space you have before the X and Y.
Oh.
It's a bit of, just to keep it clean. It's good to keep the code clean. So now they will survive for the entirety of the program. And this is called putting variables in global scope. And when you have a variable in global scope, it is created once and will live on. This isn't the best thing you want to do, but this is good enough for now, and it's simple enough for that we can learn. So what we can do, we can just hit play again, and you will see it's the same. We will get the same result. But what we can do is we can update the values in draw. So let's try that. So how would you update the X and Y value in the draw function? So it is a variable. You would like to assign it to a new value.
Well, I need to call that variable.
Mm-hmm.
But which function do I use for that?
You don't call them. You can just use them directly. So you can say X is equal to...
I don't know.
Yeah, let's 50. Try that for now. So X is equal to 50. Okay, and if you run that code...
Oh.
Mm-hmm.
We have 2 boxes.
Yeah, because you drew the first one, and then you drew a second one that was moved a little bit.
Yeah.
So let's put a clear function above everything, which will prevent us from leaving behind the things we drew before. Okay.
Hit play.
Yes. And you only get one box that is moved a little bit. Okay. Let me do one thing. Why can't I can't minimize.
You can snap it to the left.
Yeah, I want to minimize this thing, but it's okay. It's okay.
Weird.
Yeah, it's weird. But that's the thing that's causing the... So if I do play...
It won't let you just snap it to the left?
No, it's fine.
Interesting window.
Interesting window. But we want to continue to update the X value. So we want to update the value, but we want to update it based on what it was before. So, and like we learned in the beginning of the show, that we can use, a variable can use itself as a value in updating itself. So what you can do is you can say X is equal to X plus 1. So try that one. Hit play.
just moving.
It's moving.
Where's it going? What happens when it hits the end?
It will just continue on forever and ever.
I'm gonna watch this. This
Yeah.
is suspenseful. Like, I'm scared.
Oh. And there it is.
It's just gone.
It's gone.
I don't know where it went.
And it will go away forever.
So it's drawing that 60 FPS.
60 FPS. And here, like we can see, is that we use ourselves as the next value. So at some point, x was 0. And then if we go through the code, I can update this myself here. X is x plus 1. Oops. So in the first round, we will clear the screen. We will draw the spaceship. X is 0. And then we will say x is 0 plus 1. So it will be 1. So we will store that value in x. We will go back to draw. We will clear the screen. We will draw the spaceship.
And then x will be
X
1 plus 1.
Be, yeah, and because the variable x here is created outside of the scope of spaceship and draw can use x. So then spaceship will use x. It will draw it with the value 1 and 0. We will go down here. This is 1 plus 1. It's 2. We'll go back to draw, go to clear, go back to spaceship. Here's spaceship. X is then 2. Y
Here's
is 1.
spaceship.
Here's spaceship. We will draw and then keep on updating.
We'll just keep updating.
Mm-hmm.
Okay.
And that's why it just kept on going to the end of the
It just disappeared. Now we don't have a box anymore.
Where did it go? Is it still going?
It's just gone. It's probably it stopped because we stopped the.
Correct. It's not because you stopped the program. All right. So then we have the x and y. We can do the same thing with y. Let's do that. Y is equal to y plus 1. And it will go
Diagonal
on
box.
in a diagonal fashion.
It's a race.
Mm-hmm. But we don't want it to always move. We want to tell it when to move. We are in control here. Correct. So there is a thing in the reference guide which is called key pressed. Here it is. It's both a function. We will do that in a bit. And then there's also a value. We will just tell us true or false, is a key being pressed right now? So let us ask our first question.
If key pressed.
Aha. You want to do that? You want to do the honors?
I can type that. So it's if
And we want to do it above the clear, and you'll see why later on.
above the clear.
Above the clear.
So if what was the function? Is it
Yeah.
key pressed?
With a big P.
Ah, yes. Pressed.
Mm-hmm. Then you close the parentheses. And then, like in a function, you do curly braces.
Oh.
Mm-hmm. Just like the function.
So true.
So if key is pressed, let me do the same thing here. If key pressed. All right.
Do we do true and false now?
No, we don't have to ask.
Ah. Just
so
leave
if,
it.
This is the same thing as doing this.
Oh, okay.
So if key pressed is true, but we don't have to do that. So if key is pressed, then let's do x is equal to x plus 1. Mm-hmm.
Oh, snap.
So if a key is being pressed, we will update the x value. So let's try that. If you just press any key, doesn't matter what key it is.
It's like race to the end. Win.
Exactly.
Nice.
So we have two issues here. It's any key, and it's only the x value. So let's fix that. And what we can do is we can ask questions within the if. Because what happens here within these curly braces is just any code. So we can also, again, ask if key, and if we go back to our little reference guide, there's another variable here called key. So this is a system variable called key, and it will contain the most recent key being pressed. And an interesting point here is it's either being pressed or released. So it's just the recent key. So here we can see if key is being pressed. Let me make it a little bigger. If key pressed, then ask another question. If the key is, so here we have the double equals. A double equals is to not assign a value, but to ask a question, are you? And for the letter B, we have to put it in single quotes because we want to, everything is a number, even the B, but it is like the number 66, I think. And we don't want to remember that if key is equal to 66, and what does that mean? So we would rather say if key is equal to single quote B. But this just means the number 66, I think, or 65. So there's no difference. So this isn't any magic with letters. This is just an association of numbers. So if you go back here, if we ask the question, is the key, let's do the key D. And then...
Oh, another squiggly brackets.
So we have what we call nested if statements. We have an if statement, and then we have our curly braces, and within those curly braces, we have another if statement, and then we can put code in these curly braces. This means that if key is pressed, and if the key is D. We will see later how we can join these things together, but it is...
Now do we need to tell it x plus 1?
There we go. Yeah, do that. You caught on. Remember the semicolon? Yeah, try it.
I'm scared. Oh, snap. Just hitting D. I'm hitting T now and nothing's happening.
Yeah.
If I hit D, it moves.
It moves.
I can hold it down and it just goes wee.
Exactly. And we want more keys now. So we're asking the question if a key is being pressed. So here's the question, is the key D? Okay, great. But what if it's not the key D? Here below, we can ask another question. If key is, let's say it's the key A. See how it's nice how it highlights the character, makes it a little orange, just to let you know that, yeah, you did the right thing. The if is a little bit blue, the variable is a little green.
Colors.
Helps you out, figure out what's going on. But what, so D is forwards in this case, A is then backwards, right? So how would you do that?
X equals minus 1.
Yeah, so try that out.
Oops. Oh,
there
snap.
we go. X equals X minus 1. So let's keep on going.
It doesn't like that very much. If I hit him too fast, it doesn't know what to do.
That's one of our bugs.
Oh, snap.
Yeah. So let's continue going. So if the key is W,
then Y plus 1.
You think it's Y plus 1? Let's try it out.
I don't know. Now you scared me.
Try it out.
I'm slow at typing.
It's fine.
No, it's Y equals Y plus. Yeah.
Try that out. Y equals Y plus 1.
Oh, no.
So let's try.
Uh-oh. It's minus 1.
It's minus 1.
Why is that? Why is it minus 1? Because it wants to go up.
So if I do it correctly from the camera's perspective, this way on the screen we have is X going in a positive direction. This way is Y going in a positive direction. So off the screen in these directions and that direction is negative. If that makes sense.
Okay.
So let's do one more. So if key is equal to S, then we have Y equals Y plus 1.
Oops.
So let's try it out. We can go this way, up, down. There we go. But do you see a problem?
Yeah.
Try moving around quickly.
Yeah, it doesn't like doing that very much.
No. What do you think that is?
Because it's not writing it fast enough, maybe?
No. So for those who are just watching, if I hit D, it will go this way. If I then hit W, it will go up, even though I'm pressing both buttons at the same time. So now I'm hitting
It's
S.
only saving the
last one you pressed. Like the reference said, if you go back to that one.
most recent key.
Yeah, the system variable key always contains the value of the most recent keyboard key that was pressed, either pressed or released. It also means that I can't go diagonally. If I hit both at the same time, it will just pick whoever won that race I just had. Who I pressed just slightly faster or slower. So that's a problem, right? If we look at this code, we're going to draw if the key is being pressed, and if the key is D, X is X plus 1. If it's A, it's minus 1, W. There's nothing wrong if we look at the code, right? But it doesn't function in the way that we expect. And the issue is we need to store in another global variable, we need to store what happened last regarding our keyboard keys. So what we have to do, if I go then to my next setup, is we need to create 2 new variables. And those variables will store what was your last horizontal and what was your last vertical direction. So let's create 2 variables here at the top. These are again both integers. We will call them vertical. We will set the vertical to 0. And we will call the other one horizontal and set that to 0. Okay. And now what we can do is we can update. Scroll down here in my example. Instead of saying when a key D is being pressed, we will update the horizontal value. Instead of saying X is X plus 1, we will say horizontal is equal to 1.
Oh.
Just the value 1. And for A, it's horizontal is minus 1. And the same thing for W, vertical. So for W, vertical is minus 1. And S vertical is 1. Let me see if I have that correct. D is 1, minus 1, W is 1, and minus 1 and 1. So now we know when we press the buttons what was our last horizontal and vertical direction that we wanted to go in. So if we would have pressed one button, D for example, we would set the horizontal direction to 1 because we want to go in that direction. And then we would also press the button W. We're not messing with the horizontal variable because they are separate because you can press both at the same time. You can't go up and down at the same time, but you can go to the side and up at the same time.
Rip yourself in half.
Yeah, exactly. If you want to have that feature in the game, that's fine. But they are separate actions, so they have to be separated. And that was the bug that we had. So, but we still want to update the X and Y value because they are still the values that cause the ship to move. So what we can do is after the if statement, after if key is pressed, and just before we draw, we can say that X is equal to X plus horizontal. Make sure I spell things correctly. And then Y is equal to Y plus vertical. So because
we don't need these as squiggly brackets because they're just...
We always want to set the values. Always want to set them. They were set at 0 initially. And then if we press the buttons...
No, they have values.
They have values. There's going to be a problem here, but...
Can we see what the problem is?
Yes, we will see what that problem is. So I press the button.
Uh-oh. I spelled vertical wrong somewhere, I think.
I can go...
Oh, here.
There we go. I can keep on moving horizontally.
No, I spelled vertical wrong somewhere.
A nice way is if you scroll to the top.
Or did I?
It's spelled wrong in the actual variable. Vertical.
Wow.
There we go.
Did I spell it right? I spelled it right everywhere else. I just, for some reason, decided that vertical is spelled like that.
Okay. So try it out. And now move.
Ah, it's not stopping.
It's not stopping. You can move, you can change the direction, but you can't stop. And that is because even though we
I
set
also can't go in one direction anymore. It's always diagonal.
always diagonal. So if we look at the code, and let's try figuring out why that's happening. So we have our value vertical and horizontal. They're set 0 initially. And then if you press one of the buttons, you set the values. But there's no place where we set the value to 0 again. And what we want to do is we want the value to be 0 if you didn't press the key anymore. Correct? So if you let go of the key, hey, let's not move in that direction anymore. Which is why also you kept moving in a horizontal direction or in an angle, because one of them is always set into some values. You're always going in some direction. If I don't do up and down in the beginning, so I press D and let go, and then I press A, I can switch the directions, because the vertical value is still a 0. But then as soon as I press S, now both of them are set. And I can change the directions, or I can go up, but I can't stop. So they're now always set to some value. So that's a problem. We need to fix that. We need to fix that bug. So we're going to introduce a new function that is a function within processing. I want to put it here above draw. It is a function called key released. It is a void function. Let's see if you can. So it's called key released with a big R. It doesn't take in anything, correct? We don't need the semicolon at the.
Oh yeah.
Yeah. There we go. Correct. Void key released. Okay. And what this function does is it will only call when you release some key. There's been a key, it was released, let's call this function. That's the only thing it's doing. It's not called every time you draw. It's not called when you press a key, but when you let go of a key, the system will call this function. And let's try one thing here, which we haven't tried before. Let's do a print. And let's just say key released. And I'm going to move my window a little bit. Whoops, not that. The other one. So we can see this. And I can do this. So if I play, game is fine. And then I let go of a key.
What is happening?
It's printing on the screen every time I release a key. So try it out. So there you have immediate visual feedback of what's going on. When a key is released, it will print out on the screen. You can also X out the little print thing at the corner. Okay. So what do we want to happen when we release a key?
We want it to stop.
We want it to stop.
So then you need to set it to. Could we do if key equals no?
Yeah, you're on the right track.
We need it, so we know key released has something. So if it's if key equals, can we still do D X equals, or then we have to tell it X is 0?
We don't want to stop. We could stop X, but that would only stop it for that one time when you release the key.
Okay.
What we do want to stop is the horizontal and vertical movement.
So vertical equals 0.
Let's do that.
So if key.
Let's go for it. So
this is terrifying. So if key equals, we'll just do D first, like we did before. I can do another one of these. If key, no, then we just do
Okay, try that out.
Uh-oh.
You got it? It's still broken, I think, in the other directions. But you fixed the horizontal direction.
But I stopped the horizontal direction.
Yeah, you got it.
Oh, snap. Now we just need to do this for every key.
For every key. What you can do is we can copy the big key setup we had here, paste it there, maybe indent the code a little bit.
Paste it here. So now it's... We need to say key released, right?
No, we just say key because it.
Oh yeah, we just change all these to 0.
Change all of them to 0. Okay. Indent the code a little bit so it's nice and clean. Shift tab.
Wait, all of this?
And then Shift tab. There you
go. Clean.
It needs to be well made. So let's try that out. Okay, but if you do like an AS move around in all these directions, there's still something weird going on, right?
It holds it down sometimes in one direction too much.
Yeah. So if we have the code set up like this, if I press in D, it works fine. If I press A, it works fine. Press W, works fine.
I'm not pressing anything and mine's moving.
Exactly.
Though.
But then I move it around a bit, do WASD, it sometimes drifts off.
Oh, there it goes.
There it goes. So that's another bug. Why do you think that is?
I have absolutely no idea. I don't know.
Okay, let's think about this.
We're telling the code to stop.
We are. We're saying if a key has been released, we depress the key, and we're asking, hey, was it the key D that was just depressed? And then we want to set the horizontal and vertical values to 0, right? But it's not working. So what we want to do is, what if we release the key, but we are pressing another key already?
Oh. Is it keeping the value of the first key?
Yeah. So we are already releasing the key, but we already pressed another key just before. So even though we wanted to stop, basically, we are messing with the order of the actions. So what we have to do, let me fix this up here so I can see it. So when a key is released, we want to make sure that not only did I release the key, but I was also going in that direction.
So you need to tell it if it's going horizontal.
Yeah. So I just released the key D.
Yeah.
I am assuming because I was releasing the key D, I was going in +1 in a horizontal direction. But there's nothing here that makes sure that when I released the key D, I was going in the horizontal direction. So I will now then introduce another thing. So before we had key pressed, and we have an if statement within an if statement. So key pressed and key. So these are like an and together. These both have to be true. You can do that in one line. So here we can say, if the key is D, and, just double and, horizontal is greater than 0.
Oh, snap.
So we're asking the question, so a key has just been released. That's the only reason why this function is called. Okay, was it the key D? The computer say, yeah, it was the key D. Okay, and were we going in the horizontal direction to begin with? Yeah, okay, then we can set it to 0. And we can do this for all. We could just copy the and, paste them in here. But we do vertical for the W and S. And for the A, we can't ask the question, was horizontal bigger than 0? Because that's not what A was doing. We have to ask if it was less than 0. And the same for W. We can't ask if vertical was greater than 0. We have to ask if it's less than 0. Let me see, double check that is, yep. There's the thing I have. So now, I might have mistyped one of these. So D is horizontal and greater, A is horizontal and less than, W is vertical and less than, and S is vertical and greater than. And then
Mine didn't seem to want to work.
Didn't seem to want to work. You see, and then D is horizontal and 1, A is horizontal and -1, W is vertical and -1, and S is vertical and +1. Yeah. So there's another problem going on here. We are running this draw anytime a key is being pressed. But we want to know, in a similar fashion to key released, to only run the code when a key is being pressed. All right, so we have another function similar to key released. If we go back, it's called key typed. So here, the key type function is called once every time a key is being pressed, and then ignores Alt and Shift and those kind of keys. So it is a very similar function to that.
Do we need to put this in the draw section only, or is it up here as well in the key released?
It is a function on its own. Okay. So let's put it above the key released. So it is a function like key pressed.
So void.
That's right, key released. So
what is it again?
It's key typed, small k, big T, and doesn't take in anything. And it's set up like that. So now we have two dedicated functions, and we have quite a bit of code now.
Woohoo!
Yeah, exactly. One function that is dedicated to the action when a key is being released, and one function that's going to be dedicated to when we press a button. All right, and what we want to do is these here, everything here within key pressed, we want to move that up into the key typed function. Let's indent that nicely.
So I can should I get rid of the key pressed function?
Yes.
And draw?
Yes. The condition there should be gone.
Okay. So I have it in key typed now.
So let's go through everything we have right now.
We're code reviewing?
A little bit. Yeah, let's go to the code review section from your end, and let me double check on my end that everything is good. So we have our setup: size, background, frame rate, and no stroke. Correct. We have our function that will draw the spaceship: a rectangle, x and y, 32 and 32. And we have our 4 variables: x and y, and vertical and horizontal. Great. Then we have 2 key related functions.
Key released. Oh, key typed and key released.
Key typed and key released. So if the key is D, horizontal should be 1 in key typed. If the key is A, horizontal should be -1.
Uh-oh, that's destroying my...
There we go.
I was wondering, I was like, that's not lined up.
So yeah, if the key is A, horizontal is -1. If the key is W, vertical is -1. And the key is S, vertical is 1. So these are just asking, we want to go in these kinds of directions anytime we press a button. We have that. So when key released, if the key is D and the horizontal direction was positive, we go and stop. We say 0. If the key was A and horizontal is negative, less than 0, we go horizontal is 0. If the key is W and vertical was negative, we stop. And if the key was S and vertical is positive, we also stop. Sounds good.
And we're just drawing all that.
And then we go down to our draw function. And what we do is anytime, so every time we always say X is equal to x plus whatever the change is, or y is equal to y to whatever the change is.
And then clear so we don't have multiple spaceships.
Correct?
And then the spaceship itself.
Correct.
So what happens when we draw this?
Hit
Wait, but did we pass?
Yes, you passed.
Did I pass?
You passed.
Ooh.
There we go.
Go back to double screen, or should I
We
draw
can
this?
go back to double screen. So I have my spaceship here, and I can move it around.
But can I do that?
Can you do that?
I don't know. It feels so much better now.
Right?
Yeah. Very, very responsive little spaceship we got going on here. Look at it dance.
The issue was that we were calling and asking a function every time, or not calling a function, asking a question every time in that draw. It wasn't dedicated to when a key was being pressed or released. It was every time we drew a draw. That's why you noticed a slight drift sometimes.
Yeah.
That was because you were doing it every time you drew, so you were always updating it. So you weren't in sync. You had two different ideas. One idea of a dedicated function when a key was being released, and then some logic in the draw that wasn't synced up with the idea that a key was being pressed. It had the right question, but we had a mismatch there. So now we have a pretty nice functionality. Sounds good?
Sounds good.
Sounds good. So let's do one fun thing before we end.
Fun thing.
Yes.
I like fun things.
So
this is an image, isn't it?
it is.
It is an image.
So a box moving around is fun.
I know exactly where this is going. This is a very specific size of emotes, isn't it?
It is, but no.
Okay.
No.
Okay.
We're not gonna have your face floating around the screen.
I was like, no, please no.
Okay. So I'm going to introduce a few things. I'm not going to explain a lot of it because we will go into it later, but this is more for fun. So generally we are done with the setup we have, but if we want some fun, let's have some fun. So we are going to create one more variable at the top. That variable is of the type p-image. Whoops, p-image with a big P and a big I. So like with int is a type, p-image is also a type. And we will go into that later. And let's just call it img for image. And we won't set it to anything yet. And then let me just copy the big long URL, which we will have in the doobly-doo. I always like that word.
Doobly-doo.
Doobly-doo. And in setup, we would like to say that image is equal to, and then I didn't copy it correctly. Image is equal to this thing. It's quite a long.
I don't have the
thing.
link.
You don't have the link.
Are you on Discord? Can you send it to me on Discord?
I can send it to you on Discord.
Discord?
Discord. So here we go. It is being sent.
Should I take the whole thing?
The whole thing.
So.
And then, yeah, img is equal to that.
Man.
So if we go through this, we have just a long URL, but img, a variable like anything else. So we see a pattern here. It's just of the type p-image. What is that? I don't know, and I don't care for now.
PImage is how I read that.
Exactly. We call it, we say that it is equal to, and then we call a function. And this is just a function, like any of the others, but it takes in a string, so text. So instead of the double quotes, instead of the single quotes we had before, because single quotes is one character, just one character. A double quote is a string or many characters.
Many characters.
Yeah. So here is a URL, and it takes in two arguments, the URL, and then we have a comma, and then the type of the image. Great. So now we have that.
I want to press play so badly. Dude, I just want to see what it is.
Well, you can press play now and nothing will happen.
Oh, snap.
Yeah.
Oh, man.
Even though we loaded the image.
Spoiler alert.
We're not using it.
We haven't told it to draw it, have we?
Correct. So where are we drawing the spaceship?
There.
And I like that I said, where are we drawing the spaceship? You didn't go to the draw function. even though the draw function is the draw function, you went up to the spaceship function because you knew that is the dedicated place to where we draw the spaceship, correct?
Yeah, we talked about this in the first episode. There's an image.
Yes.
We put the image here.
Yeah. So there's a function. Let me just put it here below called image.
Wait, if we put the image in the void setup, isn't that going to put the whole background as this image?
No. If you put it in the setup,
Yeah.
the setup is going to be called once, which means that we're going to load the image once.
Ah, okay. We're just loading the image into the
variable.
Ah, okay. Got it.
And
Got it.
an interesting question also could be, but wait, variables can only store a number, and a variable is only a number. Then how can you represent an entire image as a number? And that is a question for later. But that is an interesting. If you think about like here's an integer, here's this thing. So how is this a number? It's not, and we will go into that later. Later. So yes, there is a function called image.
Yep.
And it takes in. If we go back here, image. Whoops. Image. Here it is. Image. They have a pretty image. So they say the same thing. They do a p image. In the setup, you do a load image of the picture. And in the draw, you say image, the image itself, the variable, and then the coordinates, x and y. So if we go to how we use it, image, the x and y, and you can also set the width and the height, so you can stretch it around and play with the size, which we can do. So we'll just say img for image. So we call the function image, and we give it's going to be 5 parameters.
Yeah. So
img.
Want to give it x and y.
The x and y. And then 32 and 32. And let's remove the rect, because we don't need the square anymore. And let's hit play. You hit play first.
Oh, God. That's so cool.
Right?
It's a little spaceship.
It's a little spaceship. And I would like to thank...
Small little spaceship.
Let me find the name so I can say it correctly.
This is so much better than my face, by the way. Like 100 times
You were so
better.
worried that we're going to have a little emoji face.
Stupid face.
I would like to thank Rio, Renyama,
Yeah.
from our Discord for doing this picture.
Pew pew.
It's wonderful. Yeah, and I can hit play and I can get a little spaceship. It's a little tiny, right?
Yeah.
So let's make it 128 by 128.
Oh,
there we
God.
go.
Oops. Oh, yeah.
We have a little NGON spaceship.
It's not so small anymore. It's gonna take it over the world.
Yeah. It's a little slow, right? Want to make it faster?
Just do, oh, snap.
Instead of the 1 in horizontal and vertical, we just turn it to a 3 in all of them. I hit play, and there we go. Now
And
it's
all of
faster.
them?
Yeah, all of them.
Ooh.
No, we have Hamish.
Zoom.
Is it working?
No,
Oh.
we're just recording for YouTube.
Zoom.
There we go.
Nice. Should we put them back to 1? Just keep it
You
at
can
1?
put them back to 1.
I didn't realize you were going to record for YouTube. That's a cool idea.
Yeah,
Yeah.
we have cool ideas sometimes.
Rather than, yeah,
We have a surprise Hamish at the end.
we missed the stream. That's fine.
It's okay. We can restream it.
Yeah.
Did you do good?
We made look at our little spaceship. It's an NGON spaceship. It moves around.
Who made the sprite?
Ryu from the Discord.
Ah, damn.
Mm-hmm.
That's real cool.
So it moves around with WASD.
Nice. Man, I'm excited.
There you go.
Cool.
And that's
Alright.
it. Yeah.
I'll leave you to it.
Yeah.
Have
So that
fun.
was
Thank
a
you.
fun episode 2 class.
Oh, you already done?
We're done. That was it.
We're done. We're done. We made a game.
Yay!
Bye, Hamish.
Bye.
Little surprise Hamish at the end. That's always fine.
Yeah.
You
That was
can actually move if you change only the positive numbers to 3, sorry, and don't hit play
Oh,
Or-
sorry.
or don't move. What's gonna happen before you do it?
I'm gonna have to hit the opposite side 3 times, won't I?
So you had horizontal as 3,
Yeah.
but the negative horizontal was -1.
Yeah.
So
I want to hit it.
Do it.
Oh, well, that wasn't any.
So
one's moving faster than the other side.
yeah, it's moving
it
faster
feels a
in
little
one
bit
of the
delayed.
directions. It moves faster in one of the directions, but not the other.
Yeah.
Because you have only -1 in one of the directions, but a bigger number in the other one.
We're all about equality here, so we're just gonna change them all back to 1.
Good. There you go.
13.
13.
Really fast in one
Really
direction.
fast. Yeah. So, episode 1. No, not episode 1.
This is
Episode
This
2.
is making a game now.
Yeah. I was fixated on number 1 here. There we go.
Sweet. Class is almost dismissed.
Class is dismissed.
We'll yeah, episode 3 will happen next week on Friday.
Next Friday.
We'll let everybody know what's going on. But as always, we'll put some description links. We didn't have a GitHub last week. I think it was a little bit more of an introductory thing.
Yep.
But we have one now, so all the links will be down in the description below for the language, the tool we're using, the reference page, the GitHub of where we are so far, so you can follow along. And
So this code bit will be up there if you want to follow along or catch up from last time. Please join our Discord. We have a Code School channel there as well.
yeah, all the links to our social channels will be down below.
Great.
Sweet.
Thank you, Gabe.
Thank you.
See you next time.
Bye.
Bye.